So hi, I'm Kristin Mulherin. I'm the president of AM Cubed and also on the board of directors for Women in 3D Printing. AM Cubed, we're a commercial consultancy focusing exclusively on 3D printing and additive manufacturing, and is focused pretty much on commercial growth. So as a recent member of the board at Women in 3D Printing, I also want to make a notice about, we have just announced the, We've just announced the new corporate memberships. So if you're interested in that, when you go back to the networking session, you'll see that there are several different tables by the sponsors, one for AM Cubed, one for Women in 3D Printing. And you can click on the Women in 3D Printing logo and it'll take you up to the membership page where you can look at all the different details. It's for the corporate membership. You'll also see the Type 3D Printing logo, which is our conference that we're going to be doing in January. So you can find out more details there by clicking on that as well. So to get started, sorry, I'm trying to get everyone there. Today we're talking about design and innovation. We want to talk about what kind of tools we can use to accelerate innovation through design and how do we make it actionable. So what we're going to do is I want everyone to start introducing themselves. It's much better, I think, coming from you than it is from me. And if you could all touch upon, what your perspective is on what kind of tools you utilize to accelerate design and how it affects innovation. So I think, Katie, do you want to go ahead and start?
Yeah, sure. Hello, everybody. Thanks for inviting me here today. My name is Katie Tucker, and I'm from WERK, W-E-R-K. We're an innovation strategy company, and we work with organizations who are undergoing a new technology adoption process, sometimes intentionally and sometimes kind of by accident, which brings us to additive manufacturing. We take a human-centered design approach. So we look both at what are the benefits, the unique benefits that a technology offers, and then what are the user's needs, or what do our customers need, or what will make our product or service better. And then we try to overlay the two, and then that's where we come up with, typically we get to play in the space of radical innovation. And that includes everything from rethinking business models to rethinking what experiences have to look like. So it's a really fun space, and I hope to see you all there. And I'll hand it over maybe to Jennifer. You're to the right of me digitally, so.
Well, hi, good morning, everyone. I'm really excited to be here and really excited to have you all join us. My name is Jennifer Arroyo. I'm the SDR manager at nTopology. nTopology, we're a design software company that's fully dedicated to solving really complex engineering problems. We have an unbreakable modeling technology that has a field-driven approach. We have something very unique to us, which are these reusable workflows that help enable really high performance designs when it comes to AM. And of course, lightning fast iterations and enabling the engineer to create really complex geometries, all that were previously impossible before. And so we work with the world's leading medical device companies, aerospace and defense, consumer goods, various service bureaus, oil and gas, automotive, making a huge impact when we're starting at the very beginning, designing for additive and advanced manufacturing. I was really thinking about early this morning, having my cup of coffee, and was like, when it comes to design and innovation, I really think it begins with the desire of making a really meaningful impact. So I'll leave it there, and I'm sure we'll discuss a lot around that. And Leanne, floor is yours.
Hi, everybody. My name is Leanne Gluck. I am with Autodesk, and Autodesk is a multinational software corporation. We make software across architecture, engineering, construction, manufacturing, and media and entertainment. And the big picture vision around Autodesk, just to tag onto that, is how do we really imagine design and make it work? And within that, we have lots of software tools and technologies to allow us to do that. One of the products that I work with is called Fusion 360, which is a platform for end-to-end workflow development for design, for simulation, for generative, for visualization, for manufacturing. And I think at Autodesk, we're really trying to create early stage visibility for engineers and designers to make decisions up front around, what are you designing? But not just what are you designing, with what machine, with what manufacturing process, with what material, and at what cost. So you're really able to think about, how do you have the as designed, and how do you have the as built mimic as designed? And how do we make it easier and easier to create what is it, our imaginations, and make that. I keep going.
I muted myself. I wanted to point out that I forgot to mention when we first got started was the Q&A on the side. Janet mentioned it, but we do want to make this very interactive, and we want to have as much questions from the actual audience out there as possible. So please submit your questions, and note that you can also upvote questions as they arise. And it looks like we've already have one that's being upvoted as I speak. So before we start going down that path, though, Leanne, you kind of touched on it, but I was wondering if the other two could mention, what do you think people need to be keeping in mind when they just very first start the design process?
Well, I think, and I'll kind of speak from my perspective in the work that we do. There's, I specialize in human-centered design. That's kind of where my background comes from. And with human-centered design, the idea or the overarching concept, if I can summarize it into one sentence, is really kind of putting the human first at the center of your problem, and then bringing the technology and the business, bringing the product or service around to solve those needs for humans. Ecological design, you might expand your ecosystem and talk about more systems, but specifically to an area where we have new technologies and new tools that are expanding our capabilities, we really try to look at them both almost in concert, right? So yes, we start with people and we say, well, what are needs? Let's rethink what the future of mobility looks like. What does travel mean? What does leisure mean? What does exercise or health mean, right? So we might have these overarching questions that drive the concepts that we develop. But really, we can't do that without looking at the new technology and saying, well, what does this unlock for us? So it's really a conversation between these new technologies and these new capabilities. And that can be everything from the machine capability to some of the support tools like Jennifer and Leanne will represent here today. But really understanding what are the unique benefits that we get from this, and how does that support the experience that we're trying to create? So for me in this space, it's about those two things, and it's a bit of a dance, right? And then from there, we can really start digging into well, how do we develop new concepts and reimagine what those experiences are?
And the idea of really in the very beginning is what is going to be my approach? And in a way, almost working backwards, what is really my use case? What are we trying to achieve here? And then work backwards. But one really key thing to keep in mind is, how am I going to be able to make many iterations of this? How am I going to, okay, great. It takes me 3 months to create this particular heat exchanger I'll use for as an example, right? Wonderful. But it took me 3 months to create one iteration of it. How about if I had 20 iterations of it to select and really determine what is the best performance? What is going to be the best selection out of, say, these 20 iterations that we worked on? What is going to be the best one to select and move forward with? Now, I know that sounds very niche, but at the very beginning of the design process, you want to be creative as possible, and you want to have tools at the handy that help support that type of environment, right? So that's what I'm really interested in talking more so about today. But it really is how can I continue to make this better? How can I possibly make this lighter? How can I make this component even smarter than what it is? And really jumping the curve of okay, great, I increased here by 20%. Well, how can I increase it by possibly 40% or 50%? Really jumping that curve and really getting to the most ideal design iteration much faster. And it's really having a look at your workflow, and it's really having a look at your tools and being sure it's not disjointed, right? Being sure that it's encouraging that capability. enabling that capability for you to be as creative as possible, but really ultimately achieve the end result of what you need to do, whether it's automotive or medical, consumer goods. I mean, literally service bureau, literally across the board of what you need to get done.
Yeah, I'd love to just add to that and really add to that frame around questions, you know. So I think when it comes to designing, and especially with additive, one thing to keep in mind is actually to let go of what you know. So, you know, there's really a mindset shift. I had a great conversation a while back with a team from UPS around unlearning the way that we think about design in order to unlock what's possible. And that the true value of additive will really be unlocked when we start designing parts that actually look radically different than anything we've seen before. And so, you know, generative designs really showed us that. It showed us with this organic tape. But beyond that, additive allows us to start the process of asking questions like, well, if I'm designing this thing, why does it need to be solid? Or why do holes have to be round? Or why do we even need holes? Why do we need, why do we need to manufacture things in assemblies? What if we could consolidate this entire design into one part? What if form followed function? What if we mimic nature? So we're able to kind of ask all these new kinds of questions and really design things in new ways. And it's these tools that we have now, different kinds of software tools, design tools that allow us to really unlock the power of that imagination to make those ideas possible.
That's right. It's all about having that growth mindset. Because remember when you stepped into the space and you're really excited, right? I want to learn more. I want to do that. It's like, it's keeping that true to yourself and true to your heart and keeping that true to your work ultimately.
So I want to touch on something that Leanne said about unlearning, because I know, Katie, that a lot of your work revolves around the unlearning process. And I think it touches on one of the questions we have as well in the Q&A in terms of how do we unlearn things and how do we get people to unlearn in a collaborative way so that they can work together, engineering and design and whoever else is in the process, how that can be facilitated.
Well, so
no, by all means, go.
Please go. Well, I guess one of the ways that that we find a lot of success in unlearning is bringing a diverse group of people together. So it's not about bringing engineers and designers together. It's about bringing engineers and designers and HR and supply chain and logistics, and maybe even some of your users, right? And maybe they're kids, maybe they're moms, maybe they're somebody very outside of the work that you do. Somebody who has probably never heard of a draft angle, right? And that's okay. So they're there with the explicit role to question what we take as part of our visceral reaction to designing a thing, right? A good designer has put in so much of their life and so much of their time to make these design rules tacit knowledge, and they've done a great job at that. But now we have to find a way that we can actively not only challenge it, but challenge it in a way that helps promote the following concepts, right? So getting people in the room early on in that early concept development and asking everybody to use their why card as much as possible. Ask each other why and encourage the challenging and encourage that unpacking. So a little bit of that is, you have to have people who have a good growth mindset, people who, who welcome that challenge, right? Who welcome that conversation. And I think framed up in the right way, it's not hard to find. It just takes that concerted effort.
Yeah, it's definitely being sure that your culture drives innovation. And it just goes really hand in hand with what Katie said. Like, you can have an innovation incubator and just have so many different people in the company involved. Like you said, from HR, it could be from marketing, sales, or from all across the board. I mean, some really great ideas are born from someone just saying, but what if, or why? It's really exciting. Mm-hmm. And don't punish any small mistakes. Like, that's not the deal here, right? It's just really encouraging experimentation and transparency and creative thinking. I think that's what the deal really is there. Yeah.
Do you have any thoughts, and maybe this is too complicated to answer in this format, but do you have any thoughts in terms of when you do hit those walls, when you do hit those resistors, those blockers, what you do to overcome that and how you get around it, or do you just say, I can't?
Yeah, I feel like this is a large part of the work that I do, and it's a little bit case by case, right? It's a little bit of relationship management. It's a little bit of, but I'll let you know what a couple of kind of guiding thoughts or mantras I use in my head, because even myself, I'm in this role all the where I guide people through this process. And sometimes, that knee jerk, that first second that you start feeling resistance, you're like, oh no, right? But you have to push past that, right? And I think one of the things that is important to know is that when people give resistance, they're giving you a communication. They're saying something doesn't feel right to me. And it's important to acknowledge first, and that's a really powerful statement that they're making. Thank you for sharing that with me. That is a gift, right? It is not something that's bad. It is a gift. And then from there, we can say, well, let's unpack that, right? What about this is making you feel prickly, right? What about this do you not like? And then kind of understanding that perspective. So in all of this innovation work, a lot of it is perspective giving and sharing. And then we can say, well, depending on what the prickly thing is, right? We can say, okay, well, let's give you a unique job, right? How do we let you take your superpower, which is to feel prickly about this thing, and you represent that thing, right? And so you can kind of check against us to make sure that we're still honoring that thing that's giving you the pricklies. And through that, what the goal is to continue to be inclusive, to continue to listen to what that person has to say, to not discount the person that's not swimming down the river with us, because we can groupthink ourselves into thinking that an idea is a really good idea because it's exciting, but that doesn't necessarily mean it is a good idea. Everything in this early, where I play is mostly in this early concept design phase, and everything is very fragile. It's on life support. We need to be able to build those out so they can be living ideas that can then grow. And we need, the overprotective mama bear or whoever, right? So we need everybody to be a part of that. So how, the question is, how do we include that in our dialogue, and how do we include that?
Yeah, and I think that beyond that too, when we look into the world and we start getting inspiration from the different kind of softwares, the different kind of new technologies, the different kind of materials that now enable our ideas to become possible, it helps us to kind of get past some of those barriers. So I even think about what Jennifer said around generative design. When one designer may be able to design 1 to 10 to 20 concepts, all of a sudden we have software is allowing us to look through thousands and thousands of different options, and not just options on how we can make something with one technology, but how we can make something with multiple different kinds of technologies. It allows us to think through costing problems that might have issues. Thought it was going to be too expensive, but if we redesigned it in a specific way, or if we changed our material, it will become cheaper. It makes us think about things like, well, what if we wanted to design and make this thing with steel, but steel's too heavy or too expensive? There's going to be a heat issue. Well, what are new materials we can start thinking about? New plastic materials that might mimic, the same kind of properties that we would need other ways that we're doing things. So I think we're able to move past some of those problems because we have so much more technology to help us solve those problems. Yeah.
I'm gonna take that opportunity to move on to one of the questions again in the Q&A. It's been voted up quite a few times, but I want to kind of change it a little bit and to keep it on focus in terms of the design side of things. And so the question is, how can 3D printing technology be used to encourage a transition to a circular manufacturing model? And I think it'd be interesting to address that from the design perspective.
Yeah. Yeah, I think a lot about, ocean plastic, and a lot of, things that are happening right now around how do you leverage 3D printing to 3D print ocean plastic. So if you can start turning waste into filament, and then turning filament into product, and how do we actually leverage design tools to help us with that is one example.
You guys have any other thoughts?
I think another place, you know, and I really love, thank you for all the votes. I love the idea of circular manufacturing, and I think, I mean, obviously we have to incorporate that in from the very beginning, right? It has to be one of our early constraints, one of our early success criteria, early drivers of decision making. I think one of the areas where additive manufacturing, maybe even like with the material set that we have now, can offer some advantage is it has the ability to, you know, to make really complex shapes and parts, right? So if we shift the complexity of a product into an area that you can then 3D print, maybe all the surrounding areas can then be used from recycled plastics, where maybe they don't need to be technically as, you know, at the same level, right? So if, you know, if we're still waiting for ocean plastic filament to become available and consistent, right? Is there a way that we can say, okay, well, how can we recycle the 90% of this and then we attach, right? So we do some kind of blended manufacturing model with additive that kind of enables a more circular,
Yeah, the other thing that just came up too as you were talking, Katie, you know, even thinking about things like combinations of tools. So, you know, what happens when we start thinking about robots plus big additive, you know, manufacturing plus 3D printing plus construction? What happens when we're able to go to a site where, let's say there's, I don't know, an earthquake? Can we potentially repurpose that rubble into feedstock and filament? Can we then turn that into 3D printed construction? So how do we start, you know, rethinking about these kinds of things? And really, you need design, you need technology to actually enable that.
Yeah, and I think it's partnering with people in the space and having that conversation about circular manufacturing as well, because that might not be a high priority for some, although it should absolutely be a high priority, and that discussion should be had. So it's really great to partner up and have those kind of discussions on how to address it and be thoughtful of it at the very beginning of the design process.
Great. I think that leads really well into the next topic, and it's based on, you know, coming out of the pandemic, how can 3D printing support all of the industries? But I think one of the things that we haven't been talking about as much is we talk a lot about the medical, obviously, industry right now. It's been kind of what everyone's focused around. What about some of the other industries out there? What are some of the other industries that have been hard hit by this, and how can, you know, there's been a lot of articles about open innovation and how it's really the pandemic has forced so many people within various industries to actually work together that would traditionally be considered competitors. And it's created this idea of open innovation, and a lot of things, if we play our cards right, we could come out with some really fantastic things as a silver lining to all of this that's happened in the last few months. And what are your thoughts on that from, you know, outside of the medical industry?
Yeah, I think it's a really great question. You know, definitely COVID won't be the last emergency, right? The next disruption we have might be a natural phenomenon, it might be a geopolitical issue, it might be another health crisis. We really need to redesign our manufacturing capacity to reduce our dependencies on any single provider, any single country. The first thing I thought of when you started talking about that was just what's happening around digital inventory and how do we collaborate to have more digital inventory so that when the supply chain does break down, we are able to get access to new parts and also collaborate on the way that we're potentially designing those new parts. So that's one thing. I actually also made me think about one of the key things that we've seen during COVID. You know, we saw in the medical industry that, you know, when people were starting to create PPE or create ventilators or create swabs or all these different things, there was kind of a need for a collaborative platform for people to work together, you know, across the cloud. And I think that that will show up in no matter what it is that we're trying to make, no matter what industry we're trying to make it in, you know, that need for collaborative software platforms to be able to, you know, work across the engineer, the designer, or the manufacturing professional is going to be a need.
I think now that more people, I mean, are going to be working from home, obviously, this is going to all be, there's going to be a lot of new interesting platforms that come out as a result of that.
Yeah.
Or there should be, hopefully. We can't all work in Zoom forever.
I think one of the things that's really exciting about that's been coming out of the pandemic too is, and Leanne, you started to touch on it, but really the decentralized manufacturing, the need for a decentralized manufacturing process, right, in the ecosystem. And I've been talking to, outside of medical, you know, people in outdoor and apparel, sportswear, and their need, right, because they have a dependency on their centralized manufacturing model. And I think what's really interesting and exciting about moving to the more decentralized model is the ability to respond regionally and locally to what those needs are, right? So whether you're talking about a shoe or you're talking about you know, something that's specific to how a region is, the pandemic is manifesting in that particular region, not only can you be a part of that community solution with the decentralized model, the manufacturers then become connectors and nodes between industries. And what happens then is that that analogies from one industry to another and relationships between one industry and another can more easily flow. And I think that kind of knowledge transfer is really exciting.
Yeah, I think actually, Katie, as you were talking, it also made me think, you know, what are the things we're going to need as we reopen the country? I mean, if everyone is so concerned and worried about being 6 feet apart or not getting germs, I mean, I went to Kaiser Permanente to get a doctor's appointment, and when I walked through the door, there was a scanner that like immediately scanned me to make sure that my temperature was okay. What will it look like? What are the new kinds of things, the new kinds of products we're going to need just to walk into a store, just to walk into a restaurant, just to go to a conference again, in order to go through an airport. I think there's going to be all sorts of new products that are going to need to be created and designed in order to meet the new challenges of today across all industries.
Absolutely. And that's what I'm seeing on my end of things, is that the people who do reach out to nTopology and come in, they're talking about exactly that. Like, hey, we're thinking about creating the scanner for when people are walking into a restaurant, a different building facility, and we're just getting, now we're beginning to design for this, and this is something that we definitely want to see moving forward. I would say, just going back, I believe someone may have asked about some industries that may have been impacted during that time. I would say aerospace and automotive, I definitely were certainly impacted. But however, with the country slowly reopening here in the United States, we're seeing people coming back into work and beginning to, you know, go forth with the projects that they're working on. So I just wanted to address that really quick. But I think what COVID has done has really brought out the best in people, in the sense of collaborating together to help create something that has a meaningful impact, that helps people. I think, I know that's very high level, but we've seen it across the board for the past few months of everyone working collaboratively on various projects to help our fellow human being. And I think that should absolutely be noted. It's great.
Great. I think we're going to have to take a pretty hard turn here to get back onto the rest of the questions that have been upvoted. So I hope you guys don't mind too much. So we have the next one is, how important do you think simulation is for design innovation process for additive manufacturing?
Oh, paramount. There's no question. In designing for AM, I mean, you could absolutely use those simulation results depending on what type of tool that you're using. If you're using something like nTop platform, you can import that shape in and continue on with the rest of your design. It's paramount when it comes to designing for advanced manufacturing. Simulation certainly is key. Of course, it's dependent on what the user is doing, but for different things like, say, sports apparel, helmet design, my goodness, the shoes, soles, the list goes on and on. It's really outrageously important. My goodness, if your use case requires that, it's like a requirement for me on our end for across almost all verticals.
Yeah.
How about as compared to traditional manufacturing technologies? How do they compare? How does simulation compare when you're designing for additive manufacturing versus designing for subtractive manufacturing?
Well, I think that, with additive manufacturing, the whole beauty of additive manufacturing is this vision of like, well, you can design it and then you can print it and you can have it, right? This really short supply chain. But in reality, when you print something in additive manufacturing, there's a strong chance that it can fail, especially when you're printing in things like metal, right? So I think, the need for simulation is really around realizing that vision of that, that short supply chain, that short design print. And I think about metal. So simulation is really important in metal additive because metal is really expensive to print. So if you design something and you print it, it's going to be $5,000, $10,000, $15,000 of a cost if that print fails. In addition, if you're, designing something that has to go on an airplane, that has to go, that cannot fail, you need to really make sure that you are, that the part that you're printing is strong enough and it has the properties that you need. And the other thing I think around simulation is that we're starting to see a shift between, in the past 5 years, Autodesk has a software called a NetFab simulation where we simulate for metal additive for thermomechanical properties for metal additive, specifically because of that cost function. And metal additive simulation was really a focus over the past few years, but we're starting to see a shift now, especially with end use production and manufacturing for 3D printing becoming more and more viable, and for polymer end use production becoming more and more viable. We're now starting to see needs for polymer simulation pop up in ways that we haven't seen before.
Great. Anything to add, Katie?
No, I mean, that's definitely, I think this in the software kind of world, that's your wheelhouse. I think absolutely, I've seen what you've been talking about as well. I think that kind of thinking about the technology adoption, or like maybe even thinking about those folks who are a little prickly about things that we talked about earlier. I think that simulation, the ability to simulate, is so quick these days, right? And it's getting faster as software and technology progresses. I think that inviting that in as early as possible is can help in the design decisions that we make, right? So instead of waiting for the part to be complete and then running a simulation, can we simulate as we're going along, and can that start being a part of the conversation that we're having as humans, right? And then the second part of that is, I think that with additive manufacturing, especially when you get into generative design and maybe organic shapes that are new to us as consumers, right? Relatively. Sometimes things being strong and feeling strong are two very different things, right? And so I think that as the more we can do to satisfy folks emotionally so things feel strong, but then also give them the analytical side to say, no, look at this is 10 times stronger, this, whatever the case may be. I think that that's a really strong
and Kristin, to your point around like what makes it different between additive versus other technologies. So the difference with additive is that if you simulate the print of a part, you notice that there's problems, you can immediately go back, fix those problems, and then go ahead and reprint it. So it's a quick turnaround with simulation for additive that you may not get in across other manufacturing technologies.
Yeah. I think this leads really well into actually to the next question. It's about quality and the speed of additive manufacturing, and I think a lot of people have that fear right now that the industry is moving so much faster than we were able to keep up with in terms of a quality and standards protocol and quality systems. And I feel like what you guys are talking about now with the simulation, it might actually be able to be transferable into facilitating that speed of innovation. What are your thoughts on that in terms of quality and quality systems?
Yeah, I mean, I think that you're starting to see industry organizations like, there's America Makes, the National Additive Manufacturing Institute, Society of Manufacturing Engineers that are working on standards for additive across the board, so that we're starting to have standards of certification for additive. You're starting to see companies think about the design to print to certification process up front. So, especially, hardware companies that want to say, you know what, when we sell our machine to a customer, we want them to know that what they print will be certified by us. So we want to have that process from design to print to certification fully streamlined. So I think, that, and I think also it goes back to collaboration of, the collaboration of national institutes, people working together, the kind of, platform approaches and standards are really helping to make sure that we have an as designed meet an as built, or the as built meet the as designed.
Yeah, agreed.
Okay. It looks like we're gonna have to skip around to a whole nother topic as well. Curious to see what you guys think on this one. Is 3D printing allows tuned functional gradient material changes layer by layer. What tools exist to design with multiple material transitions, voxel by voxel?
That's a very technical question.
It's a very technical question. Is that might be a bit outside the scope of what your guys' focus is?
Can you just repeat? Yeah. Will you repeat the question one more time?
Sorry. It's essentially what kind of tools are out there to design with material gradients. So if we're transitioning from one material to another, what kind of tools out there to help design with that? You don't see that a lot, I think, in current 3D printing with the current technologies. There's not a lot of printers out there, I think, capable of doing that kind of printing. So I'm not sure if the tools are available to design for them.
No, but it's a great innovation idea. So we should get on top of that.
All right, so we have a similar question from before. We were talking about the external blockers essentially, and I think we can look at the external blockers and the internal blockers. So the people within the design process. So when Katie was talking earlier about how to get past those hurdles of the people who are a bit afraid to go down that path, I view that more on from a management perspective or potentially as a customer perspective. One of the questions here is, how do we get engineers and designers on board? Is there a different answer to that question, or is it the same thought process?
I think the only change I would offer here is really kind of talking about like this organizational change that has to happen within that design community. Maybe it's a company, and the best model that I've seen is when we, and this is going to sound a little cliche, but I'll expand. But to have that top-down support and that bottoms-up excitement, right? And usually what we see is that we have top-down support, meaning we've got the money, the time, we're going to support this change, support exploring this technology, support exploring the redefinition of the product or service that we offer. And then to really harness and garner and feed that bottoms up excitement for a new technology, excitement for unlocking new capabilities. A lot of our designers and engineers are tinkerers, and it's not a secret how to get them excited about exploring something new, right? Unfortunately, sometimes what we see is that sticky middle part, right? So maybe that's your first level management. Maybe it's a little bit above that, right? Where they're really stuck in the middle between these two groups, right? So how do we? My question that I often look at is like, well, how do we support that group? I feel like that's the one that we can really make a lot of headway with. I think for the engineers and the designers, if they're being told what to do and you only have that bottom down kind of directive, of course that's going to breed resistance, right? But so I think it's kind of a two-pronged approach.
I think
hopefully
that actually ties in really nicely with one of the other questions in terms of who's leading the charge. Who's essentially, is there any one group within an organization that is responsible for leading the charge? Is there one group that you've mentioned that maybe the first level managers are going to be probably one of your bigger groups of blockers potentially, but who ultimately is responsible for driving innovation?
Yeah, and are they fostering a great environment for you to test new ideas? It's a huge thing.
Is there any one group that potentially has the greater potential to invoke change? And how would they do that?
Gosh.
I've seen it work with different companies. And I almost think it's not the group, it's the individual, to have a real change agent who happens to be, what I think the benefits that we see about change that's driven from like R&D groups or innovation groups, or sometimes even really progressive continuous improvement groups, is that they operate outside a little bit of the core design process, right? So they, given the right culture of the organization, they can come in as an outsider and say, hey, I've got something new I want to talk to you guys about. Sometimes it's just a really, really strong design team within the bigger design, maybe they just do a subsystem, but they are really great at activating change. And so if they work on, a specific part of a chassis, but they also have really great influence, that might bleed over to, a body system. So unfortunately, and this isn't the easy answer, I really think.
So what have you guys seen? Do you have examples of that any of you guys have seen in terms of what makes someone truly a successful change agent?
Yeah, what I've seen has been someone being really that internal champion who is like obsessed with a new way to design. Like it's fully persona, it's fully mindset. And where I've seen change happen is to where either their director or a head of a department, a head of R&D, head of technology, innovation, trusts that internal champion. And it's like, yes, if this person says this is the right tool and or tools or workflows that we should have to invoke this kind of change and to be able to develop our products faster and smarter, then yes, I fully agree with Katie. It really, the experience I've seen across the board has been like, it typically is in some sort of internal champion who does have a decision maker has their back, who's like, okay, yes, here are proven out workflows, here are different milestones that they were able to hit within the projects that they're working in, and this is working. I back this up. Let's go ahead and move forward with something like whether it's a new tool or it's a change to design, right? It could even be something, I know it sounds very broad, but it really starts there. I would say the internal with the decision maker type really, really having their back, or some sort of incubation kind of hub to where, innovation kind of hub to where they were able to complete different projects with different new tools or different approaches, and they were able to get outstanding results. And then it's like, great, the proof is in the pudding. Here we go. Let's move forward with the new way.
Right. Well, I think we have one last question to kind of wrap up where each of you can kind of touch on is a good one. And it's really, what are some of the things we could be considering 5 years from now? And I think recently we've been talking a lot the last couple of years about topology optimization and generative design. What are the conversations that you think we're going to be having with regards to design as it applies to additive manufacturing 5 years from now, 10 years from now?
Woo. I love that question. I do. Immediately what comes to my mind, and I'll keep this short and brief, is really to continue to embellish upon the simulation and using simulation to help drive the right results that we need to help shorten that design time. But I think that we'll take the conversation even further when it comes to the main output. Like, great, how could I take this large mesh file and get this over to my printer? There could be a lot of different roadblocks when it comes to that. So I think that's going to be a huge thing of having one single connected workflow when it comes to the very beginning of designing for advanced manufacturing and the different components that need to be put into place, and then your output. And then realizing, hey, is titanium going to be better for this? Is stainless steel going to be better? A lot of materials is a huge part of this conversation as well. of what is going to be best, and a cost. The bottom line is cost. How can we, if we switch materials, will that reduce our costs but still maintain the structural integrity of what we're designing? So it's very much to say the conversation now, but how can we make this easier? And then how can different algorithms come into play and offer out of the box really great design iterations for you to consider, like, hey, is this the best lattice that I should be using for this component? Hey, am I on the right path here when it comes to these simulation results and these shapes that I'm bringing in to help drive the design of this component that I'm working on? Is this right? I see tools starting to help you make those right decisions even faster. I mean, a lot of this is still going to be down to great engineering. That's you're never going to replace the human aspect of an awesome engineer. However, you can have tools to help guide them along the way to what is going to be the best result that you could get at the end. So it's really the single connected workflow. And then it's going to be things that make a really meaningful impact. And I think collaboration across the board between different, collaborations, partnerships, say universities, different companies, different printers. I think that's going to be huge for us in the next 5 years to accelerate us forward.
Yeah. As Jen was talking, it actually took me a second almost to process that question previously around voxel-based design of multi-material components, but thinking about what's possible in the future kind of triggered, Autodesk acquired a company back in 2015, I believe, called Monolith, and actually that was the first design software specifically developed for voxel-based design and multi-material. And that technology has been integrated into Autodesk software. But what made me think about it was around what happens when our software enables new kinds of things. So when it enables us to look at things like impact and energy absorption, when it enables us to have distribution of both soft and hard materials, so we can do things like create interlocking joining, or we can create soft robotics where a robot needs to interact with a world where it's a soft robot with a hard skeleton. What is that going to look like in terms of design and applications of the future? What will products look like when you have better ability to do things like heat transfer, and or increasing optical properties? So I think as our software gets better and better, we'll start to really see interesting new applications in the future take advantage of those new software technology.
I think the only thing I'd like to add to that, and it's almost a little bit of a piggyback, right? I think that it's amazing how fast we're progressing, how the software is supporting adoption and helping make design decisions based on what your performance criteria are. And one thing that I think is, well, two things that I think are really interesting in thinking about 5 years from now, which really isn't that far into the future, right? Is one is kind of workforce development, right? How do we transition, right? How do we add this in to the suite of manufacturing capabilities that we have here, and how do we create a new competitive advantage for a region, right? So the regions that take this on in our country or around the world, and encourage that workforce development, I think will have an economic benefit. The second thing is maybe a little bit more, both are dear to my heart, but maybe a little bit more personal. And it's really kind of questioning, like, well, what is the role of the designer, right? What is the role of the engineer? And it's not to displace either, right? But as additive manufacturing and software tools kind of democratize the design process and the manufacturing ability and capability, how do we, as designers and engineers and experts who have formalized training, and how do we start to guide that conversation and create a new relationship? Maybe with the open source community, maybe with young people coming up, just starting to get into into design for additive. But I think that there's a real opportunity there, you know, to kind of help us as a society, help us as a community, push us further by being inclusive and kind of helping to set up, you know, whatever that looks like, but relationships.
Yeah. One thing I'd love to see 5 years from now is I'd love to see the vision of, you know, global on-demand distributed manufacturing become real. I'd love to see, you know, really agile you know, factories that can retool quickly. You know, that we're able to design systems and tools that are more agile. We're able to minimize points of failure and have, you know, quick response times. You know, I think that's a vision that has been around for about, I don't know, 10, 15 years now. We've seen companies like Fast Radius start to bring that vision into fruition. And we'll be really excited if the, you know, on-demand global distributed manufacturing, configurable microfactories, which enable local sustainable manufacturing, really does become the reality of the future.
Sorry, keep muting myself, sorry. So we do have a lot more questions, but we are out of time, but we still have the networking session following this. So for those of you that were not here before 8:30, please join us for the networking sessions. It's really easy. Have your mic and camera on. You can join one of the tables. The tables are organized by region. So if you do want to try to find people from your local area, that might be a way to do it if you want to go join a table from wherever you're located. And I think the rest of you hopefully will be sticking around as well. So you can hunt down any of these ladies if you want to ask them anything one-on-one, or at a table of 6 is the maximum. So, and just looking forward, I want to let everyone know we are going to continue to do these panels on a monthly basis. The next 2 are scheduled, one for July and either the end of August or early September. And they'll be on the aerospace industry and how 3D printing is affecting the aerospace industry. And then also we're going to do one on sustainability. So keep your eyes peeled for those. We'll be sending out announcements probably in a couple of weeks for the next one. So we'll see you all at the tables.
Thank you.
Thank you so much.
I think